Now let's look at the absolute value inequalities and how we'll solve them. This is going to be a little more involved, but again, if we break it down into separate problems and work on them one by one, we can build up the solution. So the key idea here is going to be that we do it very differently depending on whether we have a less than or equal to, or a less than, or if we have a greater than or greater than or equal to. These are going to be very different cases. So let's see why. So I'm saying that if the absolute value of x is less than or equal to k, so if that's our starting point, then we're going to end up saying that x is between negative k and k. Or if you want to think about these separately, that x is less than or equal to k and x is greater than or equal to negative k. All right, so why is this the case? Well, think about it. The absolute value of x is one of two things. It can be x, it can be negative x. So if you have the case where absolute value of x is just x, you get x less than or equal to k. If you have it as negative x, then if you wanted to say that was less than or equal to k, you'd have to divide the negative over, which would mean you would flip the sign, and that's what you would get. Now we're going to think of this as our end case, because I need both of these to be true for something to be a solution. All right? So I like to think of it as less than means and, or in other words, think of less than. So that's just a little idea you can help remember. All right, so now let's go to the other case. So if we have the greater than or equal case, then what we're going to actually say is that that means that x is less than or equal to k, or x is greater than or equal to, x is less than or equal to negative k, or x is greater than or equal to k. All right, so most of the time I'll probably do it the other way around. X greater than or equal to k, or x less than or equal to negative k. Okay, so, and this is true because, again, absolute value of x could just be x, it could be negative x. So in the case where it's x, you would just get x greater than or equal to k. In this other case, you get negative x greater than or equal to k, but again, if you divide by the negative, you get x less than or equal to negative k. This is going to be our or case, because we can't have both of these be true. So think of this as greater. This is our greater case. So when you have greater than or equal to, you're in the or case. If you have less than, you're in the and case. So now let's see some of these in problems, in some examples. All right, so as soon as I see this first example, absolute value of x minus 5 less than 2, all right, I immediately realize it's an absolute value problem. So it's going to take breaking it into 2. Now I see that it's absolute value inequality. So I need to identify, is it the and situation or the or situation? But that it's a less than, this is an and situation. So I'm going to say, break this into two things. First, it's x minus 5 less than 2. In other words, it's the original problem as if there were no absolute values. And I also need x minus 5. Now I switch the sign, greater than, and put a negative on the other side, negative 2. So x minus 5 less than 2 and x minus 5 greater than negative 2. Now I'll solve these individually and put the answer together. So this would mean over here, add 5 to both sides, x less than 7. And over here, add 5 to both sides. Negative 2 plus 5 is 3, so x greater than 3. So that describes my solution. Now we're doing an inequality, so we have a whole solution set, so we have to do those different ways of representing this. So in inequality notation, now this is one region, so I should be able to put it together. So the smallest thing is 3, because x is bigger than 3, and then x is less than 7. So 3 is less than x, which is less than 7. In interval notation, that would be 3 to 7, not including either endpoint. And graphically, 3, 7, open, open, everything in between, or again, if you like the parenthesis to parenthesis version. Now moving to the next example. Okay, so again, take a look. We have solve absolute value of 3x plus 2 greater than or equal to 4. Identify first. It's an absolute value problem, so it's going to be split into 2. Now, I see that it's an inequality as well, so it's an absolute value inequality, so I need to decide, is it the AND case or the OR case? But it's great OR, so this is the OR case. So I go ahead. The way I break it down is the same no matter which. I say 3x plus 2 greater than or equal to 4. Basically, just the problem without the absolute values. Or 3x plus 2, switch less than or equal to, and switch to negative 4. Now I have my two separate inequalities. I'll solve them and put it all together. So on the left side here, we get 3x greater than or equal to, subtract 2. So we get 2, divide by positive 3. So we get x greater than or equal to 2/3. Over here, I get 3x less than or equal to, subtracting 2, I get negative 4 minus 2 is negative 6. Again, divide by positive 3. And x is less than negative 2. So this is the OR situation. Now, these are two separate regions, so I can't write them together. So when I go and I do my inequality version, I'm basically saying that x is less than or equal to negative 2, or x is greater than or equal to 2/3. I can't write that as one inequality because it's two separate regions. We'll see when we get to the graph. As an interval, again, I have to write this as two separate intervals. X less than negative 2 would be negative infinity to negative 2, open, and then union 2/3 open. Whoop, I'm sorry, these should be closed, as that is or equal to, and this should be closed or equal to infinity. So on a graph, we would have something like this. Let's say negative 4, negative 3, negative 2, negative 1, 0, 1, 2. Okay, so we would have negative 2, including negative 2, and everything back. Then over here we would have 2/3, so that's about 2/3 in there. Again, closed, and everything forward. Okay, so you see if you wanted to use brackets in your graph. Okay, so you see two separate regions. So an answer can be in one region or the other and be a solution. Whereas with the AND case, you had to be in the one region. So that's the difference there.